All right, so this category is graphing exponential log functions. So it is exactly what it says it is. And we're going to graph this function f of x is equal to 5 to the power of x minus 8 on the axes below. And we must plot the asymptotes and any 2 points with whole number coordinates. So just like before, we're going to be using Desmos. So let me get rid of this old stuff from Desmos. Okay, so I already have Desmos pulled up on the side here. I think you guys all know how to get to Desmos.com. It's literally just Desmos.com, and then you press the graphing calculator button in the middle, and it brings you here. Otherwise, you can just type this into your URL, and then it will bring you here. Okay, so I'm going to type f of x equals 5 to the power of x minus 8. Okay, so I get this graph, and then I'm going to add a t-table so that, because I know that it's a little bit hard to find whole number points like this. I know you can find some, but it's a lot easier if you have a t-table. So just to remind you guys how to add the t-table, you press plus and table. And then in your t-table, you want to make sure that it says x and f of x. So whatever little number they give you here, like mine said x sub 1 with a little 1 here, I want to get rid of that, so it's just regular x. And then I want to go from, it looks like negative 12 all the way to 12, simply because the x values here start at negative 12 and then they go all the way to positive 12. So I'm just going to go ahead and type all these numbers in. And it starts filling it in for me. Cool. Okay. So obviously we don't have to be graphing this number where it's completely gigantic, but let's find some nice whole numbers like 0 and negative 7 and 1 and negative 3. So I'm going to plot those. So 0, negative 7, and 1, negative 3. Those are nice numbers. Okay, and strangely enough, it says negative 8 over here twice. It doesn't actually equal negative 8. It's just that Desmos is rounding it. You see how it gets closer and closer to negative 8? And then it just got so close that instead of just giving you negative 7.9999999, it just rounded it to negative 8. However, this is actually your asymptote. So we have a horizontal asymptote at negative 8. As you can see here in our graph, it gets pretty flat at the negative 8. And so this is actually where your horizontal asymptote is. It's where your graph approaches and gets really close to, but it doesn't actually touch. I know it says it touches it here, but this is just them rounding it because they just don't want to type so many 9s, I guess. So this is your horizontal asymptote, and it's horizontal because it goes left and right. So I'm going to click horizontal asymptote. And then right now they gave me the horizontal asymptote at negative 11. That's wrong. Remember, our horizontal asymptote is at negative 8. So I'm going to drag this until it's at negative 8. Okay, so this is pretty much it. Before I submit it, are there any questions? Let's submit this answer, and then we'll do another one. I'll try to get 2 exponential examples and 2 log examples. So here's another exponential. F of x is equal to negative 3 times 2 to the power of x. So I'm just going to delete this. Negative 3 times 2 to the power of x. There we go. And as you can see, here's your new graph. It goes upside down this time. And let's find out what our asymptote is and what our whole number points are. So I'm going to put these 2 points because they're nice whole numbers. So 0, negative 3. And then 1, negative 6. Oops. There we go. And then what would our asymptote be? So I can see that it gets flat right around here, but what number is that? So if you look at your t-table, you can see it's negative 0.5, or sorry, negative 0.75, negative 0.375, negative 0.18, negative 0.09. It's getting closer and closer to the number 0. I know that one doesn't look like a 0, but if you actually click it, it's times 10 to the power of negative 4, which is like really, really tiny number. So this is essentially showing that your graph gets closer and closer to the number 0. So that is going to be our asymptote, and in this case, it is horizontal. Oops. So you have an exponential equation, your asymptote is going to be horizontal. And they gave it to us here. This is wrong. We want it at 0. So I move it there, and then now our graph looks the same. Any questions on this one? Okay, another exponential. I don't know why they keep giving me exponentials, but that works out. So we have f of x is equal to 2 times e to the power of x plus 1. So I'm going to delete this. 2 times 3 to the power of x plus 1. Okay, so it doesn't want me to type it there. So when I have an exponent that says x plus 1, and it doesn't want me to type plus 1 in the top part, look at my cursor, it's in the top part, but then I press plus and it becomes over here. What I do is I go in front of my x for the exponent, and I type x plus 1 here, and then I delete the last x. And then for some reason, that's how it lets me do it. But yeah, just so you know, that's how I type this. So I have that, and then here's our graph. Let me show the whole thing. Okay, let's look for some whole number points. Negative 1, 2, okay. 0, 6. Okay, and so plotting those 2 points was the easy part. Now we need to find out where our asymptote is, which is the harder part. So if you look on the graph, you can kind of tell that it gets flat right around here. So now we need to wonder what that number is. And so we can take a look at it from here, where it gives you the y value of 0, and it gives you another y value of 0, and it gives you another y value of 0. I guess if you zoom out enough, it will just straight up tell you in the y value because it's rounding it. So if you look over here, it's not actually 0, it's just a really, really tiny number, like 1.129 blah, 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 times 10 to the power of negative 5. It's like a really, really tiny decimal number. And so it is really, really close to 0. And so that's another way you can tell it's 0. And then you can also take a look at the numbers and what number they are approaching, like 0.6 repeating, 0.2 repeating, 0.07 repeating, then 0.02. These are getting smaller and smaller, and then even smaller and smaller and smaller and smaller and smaller, therefore getting close to 0. And remember, if you just click here, I guess if you're zoomed out enough, the y value will just tell you straight up that it is 0. Okay, so hopefully that helps with the asymptote portion, because I know it's a little bit trickier to see on exponentials, but I guess if you zoom out, then you just click on the view in the flat area, and then the y value will tell you. So the 0, it stays the same here. So your asymptote is at 0. Another problem. Okay, so we got a log problem. So then I'm going to go here, delete all of that, and type the negative 3 log base 2. Remember to type a base, you press the shift and the minus button. Shift, minus. So that gave me my log base 2. That's minus 1. Okay, so that's a little bit hard to see. Let me zoom out. There we go. So now we have a log function, which is facing this way, kind of like an L shape. And then the asymptote for log functions are always going to be vertical, okay? So if it says log, it has a vertical asymptote. If it's exponential, like there's no word of log here, and it has an exponent. If it's exponential, then you have a horizontal asymptote. If it's log, we will have a vertical. I guess I can put it in right now. Okay, so let's see. Should I do the asymptote first since I already put it here? Let's do that. Okay, so to find the asymptote of a log, it's a little bit easier. You just scroll in your t-table, and it's the first number that says undefined. So in this case, 1. because all of these are undefined, but the first one that was undefined was the number 1. So I'm going to drag this vertical asymptote to the number 1. And then let's find 2 points that have whole numbers. For example, 2, 0, and 3, negative 3. Okay, so 2 zeros there, 3, negative 3 is there, and the first number that it became undefined at was 1, so that is where your asymptote is. And any questions for this one? All right, so let's submit this one. Let's do some more examples, hopefully some logs. Yay, another log. Okay, so we have log base 2 of x minus 8, not in parentheses, so I'm going to do that. Okay, so as you can see, here is our graph. And so with logs, you always have a vertical asymptote. And where is our vertical asymptote? Is the first undefined number. So we have all these undefined. The first one that is undefined at is 0. So I'm going to drag this over to 0. Okay. Then you just find any whole number points, like 1, negative 8. So let me put that there. And then 2, negative 7. There you have it. That's your graph. Okay, so once again, I just found some whole number points and I put my points there. So 1, negative 8, I chose that one. 2, negative 7, chose that one. Could have chosen 8, negative 5, but I didn't. It's fine. You can still see that it's there because once you put your asymptote at the first undefined number, which is 0, so I put it over here at the 0, then it kind of forces the shape. Okay, any questions on this one? And submit. And cool, I wanted an exponential and they gave me one. So let's type this in. Negative 3 to the power of x plus 1. So there we go. And remember that when you have an exponential, your asymptote this time is going to be horizontal. And then we can figure out what that is. You can see over here it gets pretty flat. So if I click it, why are they not staying? Okay, there you go. So negative 12, 1, negative 11, 1, negative 10, 1. As you can guess, that horizontal asymptote must be at 1. So let me move that over there. And then I know it doesn't say 1 over here, but you can see it's like 0.99999, 0.9999999. Like they're really, really close to 1. So I guess it does help if you zoom out a lot on the graph, it will round it for you, right? Like Desmos doesn't want to be putting 0.9999999. They just round it to 1, even though technically your graph doesn't touch the 1 because it doesn't touch the asymptote. But it does help to visualize where the asymptote is just by zooming out on the graph so that the y value can accurately show you what your asymptote is. So we're approaching 1 here, but let's find some whole number points so that we can plot them. For example, 0, 0. So let's plot 0, 0. And then 1, negative 2. Let's plot that. There we go. So I plotted these points, 0, 0, 1, negative 2. I could have chosen 2, negative 8. That would have fit here on the graph as well. But as you can see, it is crossing through it. I don't need to choose that point. And yeah, there you have it. This is our graph. Are there any questions? And submitting. Okay. So we've done 6 examples. I think that should be enough. But if not, you guys can, of course, call me over into your breakout rooms. And so I'll end the recording here.